is Peter Barrow. I'm founding director of Plaztuff International Limited. I've been developing plastic concepts for the last 30 odd years. Well, Plaztuff is a high molecular weight polyethylene. It's been developed to replace steel, stainless, aluminium and a whole range of materials and a whole range of different applications. Plaztuff is essentially a product that we have developed ourselves using a master batch that creates the final product, and we develop it to the customer's requirement and specification. So we colour, UV stabiliser, any additives that they require or anything that required within the material is added as part of a master batch, and that defines Plaztuff from any other high molecular weight polyethylene. Plaztuff came about around 18 odd years ago when we were I guess morphing from one business to the next. We'd been in the business of repairing rigid plastic, which was crates, bins, all sorts of things that were being used by different industries for the cartage of different types of goods. And we were set up as a repair business to repair those crates, and there were large volumes of them. And as the volume of plastic crates grew through the 90s, so too did the cost of those crates started to come down. So towards 2000, we ended up with a business that was, I guess, overpricing its repair system. So we had to look at other opportunities, and we started building tanks for the motorhome industry using polypropylene. We were asked to look at some larger type products using polymers, and weren't exactly happy with the specification on the material that we were currently using. So that's when we started looking at the high molecular weight as a possibility, but it wasn't being used to fabricate anything. So we then had to work on, okay, how do we change this material from one that was primarily used for blow moulding and vacuum forming to one that we could fabricate with, and that meant finding a way to get 100% residual strength in the welding, and to really build it to our customer's requirement. And that required us to do quite a bit of research and looking at the material and wondering, okay, so how do we manipulate this material to suit our application? And so we started working with a company called Clariant. And Clariant make master batch, and master batch is a bit like all the ingredients you put into a cake other than the flour, and flour would be the high molecular weight polyethylene, so that comes in a bead form, and that's the bulk of the material, and then everything else that you add to it is essentially the master batch. And it was that master batch that became crucial to the success of Plaztuff, because we then were able to manipulate the material to an extent that we could use it in a whole range of applications that suited our need. And that was to be able to fabricate with it and weld it and get 100% residual strength on it. So essentially that's how the growth of Plaztuff came about. I guess the big difference is that, first of all, Plaztuff is not just a sheet, it's a whole system. So it's built around not just the calibre of the sheet and the quality of the sheet and the specification and material properties of the sheet, but also the follow-on for fabricators, in that we provide a set of protocols and everything that goes with that allows you to build something to your specification for your customer. And I guess it's that whole process that is licensed to the end user that fundamentally protects the individual in terms of giving them a system that actually works and functions and provides them with the ability to be more competitive and provide something that it reduces weight, has better functionality, it's more environmentally inert, it reduces carbon footprint in just about everything that you put it into, and gives them a whole range of application and properties that are second to none, really, in terms of materials that you could otherwise use. So Plaztuff is basically being built by engineers to facilitate what engineers actually do, and that's fabricate in the same way that they would fabricate a sheet of steel or a sheet of aluminium or a sheet of ply or fiberglass for that matter. And so it allows us to build any of those components using plastic or using polymers like the high molecular weight and achieve the same results but better in the respect that we reduce weight and we provide something that doesn't need to be painted and does a whole lot of things that are different in terms of the end use. Of course, when you start looking at various industries, if you look at the transport industry, for example, the benefit is huge. It's the reduction of weight, and being able to take weight out of any product like a truck body or a truck tanker has huge benefit straight away for the industry. It goes without saying that the minute you reduce the weight, you reduce the impact on diesel, you reduce the wear on tyres, you reduce the wear on roads, you give the company the ability to carry more for the same gross weight, which is extremely important. You reduce the tear weight of the vehicle when it's empty, so that he's using less diesel when he's travelling around empty. All those characteristics, when you explore the possibility with Plaztuff and what that actually does for you, it's huge. In the marine industry, the question is really essentially the same. It's a reduction of weight, makes it easier to manufacture product like boats, for example, where you can reduce weight and it's easier to transport on the road. On the water, you require less power to push it. All those sort of things become paramount. But also you have a material that's environmentally inert. So in a saltwater environment or any water environment where there's things like salts and things that are essentially affect the material that you would otherwise use, you don't get rust, rot, you don't get osmosis with or electrolysis like they do with aluminium, or osmosis like they do with GRPs. And so you've got a material that is fundamentally inert, and once again we can build it to the customer's exact requirements. So colour, stabilisers, all those sort of things, we can demand the highest quality and essentially give them a life that will outlast any other material out there. Absolutely. Even when compared with steel, which is extremely cheap, if we look at the cost of steel as opposed to the cost of Plaztuff, and it may be that Plaztuff is 6 to 7 times dearer per sheet weight. The difference is that you're reducing the weight in a tanker, for example, by a third. So that brings back the cost to within, twice the cost of steel. Then the fact that you don't have to paint it, the fact that you build it a lot quicker, so it's a lot lighter to handle. So we can put a tank cylinder together with our butt welding systems within half a day. The same tank cylinder you couldn't weld together completely in a steel system. If you roll formed it and then welded it, it'd take you a week. And so suddenly we're able to put things together at a lot faster rate, making it more economical to build. And then if you build a steel tanker, for example, you have to then grit blast it or sand blast it, and then you have to put a primer on it, and then you have to put some sort of caustic paint system on it. Well, we don't require any of that. Our colour's already built into the material. So when we weld it, the colour's built into the weld rod, and everything is specified to the exact same specification. So when we finish the product, it's finished. Once we create that cylinder, that's the cylinder. It doesn't require to have any of these other systems done to it. So that negates cost and takes a lot of cost out of the process. So the process is quicker, and we can negate a lot of the cost that's involved in process. So that brings the price down, and suddenly we're there at the same level that steel is. And if we can be at the same level at steel, then we can be cost effective with anything. Like we can be half the price of stainless steel. We can be, we can be competitive, way competitive with aluminium. We can be competitive with glass reinforced plastics or, fiberglass. and all those sort of things we're very, very competitive with, because you don't need to go through some of the processes that you need to do with these materials. For example, a stainless steel tanker, in order to make a stainless steel tanker usable, you need to go through and passivate all the welds once you've welded this thing together, in order to make those welds perform in the way they should do. And even that doesn't allow for the tanker to give the same sort of life that you'd get out of a Plaztuff tanker. So there's a lot of things that start to make sense when you're building this, and in terms of cost, then we can be very, very competitive. Well, Plaztuff's a new opportunity. It's an opportunity that's been tried and tested in a lot of jurisdictions around the world, in other words, a lot of countries. And it's been successful wherever we've gone. I mean, it takes time to happen, so investment, as long as people don't expect an instant return out of their money, then it's a good long-term bricks and mortar type investment, where you're going to get a steady income, a steady investment, and as we grow this business, these guys will grow this business throughout the US pretty quickly under the licensing regime. And that makes it attractive to an investor, in that you'll earn well above anything that you could ever perceive as a bank rate, or even in a lot of investment, with a reasonable amount of surety, in that the outcome for this, because of the benefits derived from Plaztuff, are huge. And we're seeing that in every country that we move into, like Thailand, like Indonesia, like Malaysia, like New Zealand and Australia, wherever there's been an uptake or an early adoption of this type of technology, we've found that these people are just, they've grown and grown, and it's kind of like having a tiger by the tail. So these guys just find that they just get inundated once they get the competency in the business, and once they get their business to a position where it can start producing product and start getting product in front of people, then they find that they just never stop. So from an investment point of view, it's a good middle to long-term investment that will yield very good return. The applications for Plaztuff are huge. One of the interesting aspects of application was that in the early days, when we first started the journey with Plaztuff, we took what we would consider a scattergun approach, where we went out to all industries, said, look, here's a new material, how can we use it? And not one of those industries that we went into came back and said, no, we can't use it. They all came back and said, oh yeah, look, we would like to use it here, or we would like to use it there. And so we suddenly found ourselves inundated with a whole lot of requests to use it in a whole lot of different applications, and that's kind of what set us on our track. And to some degree, we had to focus back in on the what we would call the easy fruit, or the low-hanging fruit, and not sort of look to some of the applications that were required a higher range of specification, higher OSH requirements, all those sort of things. So we then started to focus on building things that didn't require the same specifications, things that could be, built at quite easily without having to comply with a whole raft of legislation and things that made it difficult to get that process happening. And so we focused on truck tankers and potable water tankers and liquid fertiliser tankers, as opposed to fuel tankers, for example, which require a huge amount of specification. We concentrated on the marine industry, boat lifters, boats, all sorts of docks and waterways, all things that were being made out of different materials but could be replicated using Plaztuff. And we concentrated on industry, conveying systems, walkways, things that we could build quite easily, and we could then, it could be used in industry without having to go through a huge process in order to do so. Tanks were another thing. I mean, tanks are constantly being built out of polyethylenes and plastics of various degrees. We've got some unique features in that our strength is higher than a lot of materials. We're an engineering grade material for a starter, as opposed to just a general grade plastics, which a lot of the rotary moulded materials are. And so we offer better solutions in terms of the product going forward. So the applications are just many and varied, and in fact every time we get in front of another engineer, they find another use for it. And so, you know, it's just one of those materials. We are entering a new age of material, and this is one of those new age materials that will grow and grow and grow and be more considered as process happens. And with the transport industry in particular looking to lighten load, looking to go to hybrid vehicles, looking to, you know, smaller trucks with bigger volumes, all those sort of things suddenly become paramount when you're looking at, you know, this type of material, and it just takes weight out of everything. So that's where the applications are huge. Well, Plaztuff, like all materials, has its limitations. Plaztuff has got a very low modulus of elasticity when compared to steel, aluminium and stainless. And so we need to build torsional strength into the material, and that we can do by using it in conjunction with these other materials and use these materials as composites. In some applications like tankers, for example, we don't need steel in them. Some of the truck bodies we don't need steel in them, but some we do, especially where they're carrying, you know, heavier loads, where there's a lot of tension on the material, where the, you know, the light load is extremely heavy and bulking against the side of the bins. We need to put something in there that actually stops it from wanting to bow, because this material has the ability to absorb this energy, but it will also it's not that piece of steel that stays rigid. This will actually bend a little bit, so you need to be able to take care of that in the process. And we advocate it as a replacement in a whole range of different applications, but there are a lot of applications where you can't use it. I mean, it's not the B end of everything, but it has a huge role to play within a whole range of industries, and it's just looking at it more holistically, being able to decipher what those roles are, and then, you know, defining them through the process. So, you know, we're not a fix-all for everything. We certainly need to be, it needs to be well engineered, the process needs to be thought through, the methodologies need to be thought out, and that is why we have licensed this technology, because that is what allows us to provide you with a surety in terms of what happens at the end of the process. Well, the future of Plaztuff is interesting. It's a new genre of material, essentially, being used in a new way. It offers a raft of solutions to a raft of industries. So I think the future is huge, and we're starting to see that in industry in general, in the countries and jurisdictions that we've shifted into already. You know, we're now looking at Europe. We're now looking at the British market, and they've got nothing like it. They are asking for it because they see huge potential for it over there. So I think the future for us is bright, and like all things, you know, we're at the forefront, at the beginning of it, and it's a long journey, and it's going to take a while for it to get to where it's really, you know, starts to become the norm. And when Plaztuff becomes a generic name and everyone is asking for Plaztuff by name, that's when I'll be happy, because that's when we will have done our job.